Hey team, Andre from High Performance Academy here. Welcome along to another one of our webinars, and today we're going to be diving into the Haltech NSP software. Not exactly brand new, but one of the advantages with the NSP software is that not only is it used for calibration of their new Nexus platform, it is also now useful for tuning the older Elite ECUs or the existing Elite ECUs. You can still buy an Elite ECU brand new, so they're hardly old. There are some pretty sizable advantages, as we will find out as we go through today's webinar with using the NSP software. So I suspect probably pretty much anyone who is a Haltech ECU user is going to make the shift to NSP. And like anything, there's a few changes, a few subtleties, a few intricacies that you do want to know about in order to get the most out of the software. So we're going to cover that as we go through today's lesson. Before we do that though, just to update you on a few of the things that have been going on around here over the last couple of weeks. And I know of late we have focused pretty heavily on the changes that are going on to our Toyota SR86 race car, and I'm going to take a little bit of a break from that for those who are maybe sick to death of hearing about what we're doing to that car. We'll cover a few more changes in a few more weeks, but for the time being, I do want to talk about one of our other projects which saw a lot of work last year, then has taken a bit of a backseat again while we've been doing some other things around the shop and concentrating on some course production. That is our Toyota FJ40 project. If we jump across to my laptop screen for a moment, this is the car as it was before we tore it completely to pieces. And for those who haven't seen this before, this is actually my daily driver, and it's a genuine 1982 Toyota FJ40 in an essentially stock standard condition. And the aim with this car was to basically produce a upgraded, modernized version while still retaining the original authentic look of the FJ40, something that personally I've always been really attracted to. As part of that, the upgrades include modernized suspension, including coilover suspension on all four corners, disc brakes, power steering, and also modernizing the powertrain with a Toyota 3UZFE 4.3 litre V8 and modern electronics. Now that's the car as it sits at the moment on our hoist. So we were lucky enough to get Tom's Offroad, which is a little way up the road from us. They specialize, as Tom's name suggests, in off-road modifications, fabrication, and Tom did an amazing job on this truck with the fabrication work, and including the coilover conversion front and rear. And as you can see, we've got the 3UZFE sitting in the hole. I'm not really after a huge amount of power for this truck. It is, after all, a cruiser, but the torque from the 4.3 is going to be a nice increase over the existing 3B diesel engine. The engine we sourced was from a wrecker, bit of an unknown entity, but it was in really good condition. One of the things I always like to do when I'm buying an engine from a wrecker and it is an unknown origin engine is to pop a rocker cover off, maybe two rocker covers in this instance, and just take a look at what's underneath. And that can be surprisingly telling in terms of the sort of maintenance that the car has had over its life. Ideally, what we'd like to see under there is a nice tan honey color, which suggests that it's had regular oil changes and hasn't essentially been abused to within an inch of its life, which is exactly what we found. If you want to get a little bit more involved, you can pop the sump and have a look there, and once you've got the sump off, it's not too difficult then to pop maybe a big end bearing cap and maybe a main bearing cap off. Actually, with the 3UZFE, the main bearing caps are a little bit trickier, but essentially that gives you the opportunity to have a much more thorough investigation. Anyway, we found that the engine was in really good condition, so it's just getting the basic maintenance items, including new cam belt, new water pump, new idlers, tensioner, etc. Hopefully that way we shouldn't have to worry about maintenance on the engine for a fairly long time. Now, on that note, one of the things that I know a lot of people will do on a wrecking yard engine is perform a compression test, and that's normally pretty easy. All it requires is that you hook up the starter motor. Even if it's temporarily hooked up just to a battery, you can turn the engine over, basically pull all the spark plugs and put your compression tester in each of the cylinders one at a time. Now, I just want to mention that in wrecking yard engines, this can be a bit of a mixed bag. While yes, it can obviously indicate a serious problem with the engine, particularly with the engines that have sat in a wrecking yard for a long period of time, what we can end up getting is light corrosion forming on the valve seats and the valves that are open. Now, while on face value that doesn't sound like the best, and obviously no corrosion would be perfect, it is a reality. And why I mention this is it can be misleading when you do a compression test on one of these engines that's been sitting for a while, because initially it will possibly be low on compression on a few cylinders, those cylinders that have been stopped with the valves open. But the reality is when we actually fire the engine up for the first time and allow it to run for 10 to 15 minutes and get everything up to temperature, generally that's enough for the valves to basically wear back through that very, very light layer of corrosion that may have formed. They seat properly. If you did a compression test after that, you're probably going to find that it's actually just fine. So I don't really have a great solution for that particular problem. I just want to mention that when you are dealing with this style of engine, often a compression test is actually a little bit misleading and may suggest that you've got a problem with the engine that in reality, once it's fired up, is just going to be fine. My suggestion is always to talk to the dealer or wrecking yard that you are sourcing the engine from. Most of them will provide a startup warranty with an engine of this nature, so it allows you to just have a bit of confidence when you build it, buying something that's a bit of an unknown quantity. All right, so what we are doing with the vehicle now, we'll just jump back across to my laptop screen. We are in the process of designing up and building a fuel tank or fuel cell for it. This was a diesel vehicle and it's not going to be diesel anymore. It's petrol and it is EFI, and that requires a constant high pressure supply of fuel. So what we did is we sourced this radium surge tank system. It's actually designed more for race cars, and it fits a universal style mounting flange, which is this kind of oval flange that we can see up here. We see this in a lot of professional fuel cells, so this just bolts straight in. A nice feature with it is that it provides a surge tank as well as a pickup, so a little hard to see here, but this is the lift pump. So this just pulls fuel from the cell, and what it does is it kind of pumps that internally and puts it into this fuel cell here, fuel surge tank here, which I think is around about 2.5-3 litres in capacity, so reasonable size capacity, a little bit under a gallon. And then inside of the surge tank we've got the ability to run, I think it's 1, 2 or maybe even 3 high pressure lift pumps, high pressure main pumps. So obviously we're not making a lot of power with this thing, so one is absolutely more than we need. So on top of that, because it is a road car, I'd like to know what the fuel level is. We've got a fuel level sender there as well. So that's the basis of the fuel tank. On top of that, Brandon's pretty handy with Fusion 360, so he designed up a bit of a mock-up of what the fuel tank needs to look like. We've got a fairly tight space that it will fit in, so we needed to work around that. And also he has added in some internal baffling, which you can see here. So this is going to reduce fuel slosh, and even though it has a surge tank, obviously that's going to be beneficial. So that's the basis of the fuel tank that we are building. Now, when it comes to building products like this, components like this, there's a number of ways of designing them and producing them, and also making sure that they are going to fit. And while obviously we've just shown you a couple of drawings there from Fusion 360 computer-aided design, I am still a huge advocate for the good old-fashioned cardboard aided design, and that's exactly what you see here. So essentially from that Fusion 360 model, the team were able to basically cut out cardboard in the shape of each of those components, tape it up together and give us a real world idea of whether that was going to fit the space, give us a bit of a sense of what that was going to look like in the location as well, what the clearance to all of the items around it were. And I will come back to what we are doing with this particular project in a moment, because it is relevant to a brand new course that we've produced and a brand new course that we are about to release. On top of that though, I have been waiting for MoTeC to catch up with their supply chain issues and provide us with a little bit of product so we can get on to the next exciting stage, which is the electronics upgrade and the wiring harness build and installation. So I'll just show you a couple of the main components. The first of those is the MoTeC M170 ECU. Incredibly small for the amount of power that's packed into it, and the M170, this particular ECU is designed around an 8-cylinder engine, perfect obviously for our application, with the top of my head I think it is 8 injector and ignition drives, but the other thing is, as you can see here, it has an auto sport connector. Definitely not essential, but the quality of the build that we're doing here, I really thought it warranted producing a proper professional motorsport harness using auto sport connectors. Everything's going to be sealed, booted, DR25, the works, as you'd probably expect for something at a professional level, albeit maybe not always in an FJ40, but bear with us. Everything that we're applying here in an FJ40, you can also apply to your own road car, race car, or anything else. It doesn't really matter that it's going into a truck. The techniques and the technology are exactly the same. Now, another item, I've got one of two here, which is MoTeC's PDM 32. And this is a power distribution module for those who maybe aren't aware of what that terminology means. Essentially, this is our way of getting rid of conventional fuses and relays, and we're going to be able to control the power supply to all of the circuits on the vehicle using solid state electronics. So basically switching everything inside this little box here. You can see, again, probably a little difficult in this shot, but we've got a large stud here with this auto sport connector, which is our main battery power supply. We've got outputs, and we've also got inputs into this as well. Now, surprisingly, for what on face value does look like a fairly basic truck, there's actually a fair bit going on once we actually sat down and I started documenting everything that was going to be controlled in terms of the circuits. We've obviously got the engine electronics, we've got the fuel system that we just looked at, including the pumps that will need to be powered. We've got thermofans, but we've also got a electric winch on the front of the vehicle, and we've got a lot of LED lights all around the vehicle as well. So that including your usual like windscreen wipers, the fan, aircon, etc., actually require quite a lot of outputs, and I was trying to do this with a PDM 32 and a PDM 16. Ended up that we actually are going to be using two PDM 32s, and we'll have a little bit of auxiliary output available still. And what that allows us to do is one of these will be fitted near the front of the vehicle, and that's going to cover obviously all of the outputs at the front, but we'll be fitting the second one near the rear of the vehicle. So this is one of the nice features with power distribution modules, is we only need to run the main power supply to the PDM from the battery, and then we will be communicating between all of the electronic components using a 2-wire CAN bus. So switching inputs or requests can be controlled via CAN. So the rear PDM can be used for controlling everything at the back of the vehicle. So the fuel pumps, which we've already talked about, but of course tail lights, the reverse lights, the LED lights bar that will be at the rear, interior lights at the back of the vehicle, and anything else that sort of pops up. Now, one of the challenges when you are using power distribution modules like this is we do have a variety of ways in which we can request an output to be turned on, and this is where PDMs really offer so much more flexibility over a conventional relay and fuse system. So where possible, what we would like to do is make these requests via a CAN message. So give you an example of this, the fuel pump, which we've already talked about a few times. So generally how that will work is when we power the vehicle on for the first time and the ECU powers up, it will run the fuel pump for a few seconds to prime the system and build pressure. The idea behind this is then when we turn the key and crank it for the first time, we've already got fuel pressure built up, so it will allow the engine to start more quickly. However, if the engine doesn't run, if the RPM is 0, maybe it stalls, maybe it's involved in a crash, then once the RPM has been 0 for a few seconds, we want to shut the fuel pump off so that there is no danger of pumping fuel through a burst fuel line and maybe causing a fire. So conventionally, that would be a request from the ECU via an auxiliary output, which we would physically wire to a relay to turn the fuel pump on and off. Now, we've got a couple of options there. We could do exactly the same and run an auxiliary output from the ECU physically as a wire to an input on the PDM and set that up just as a switched input. Basically, for all intents and purposes, as far as the PDM is concerned, a digital input, just like we were flicking a switch physically on or off. But we can do this via a CAN message as well from the ECU, requesting the fuel pump to turn on. We could do some tricky stuff as well if we've got multiple pumps in terms of monitoring 2 pressure pumps, and maybe if one of the pressure pumps is deemed to be faulty, we could switch to a backup pump. So there's a lot of flexibility there. Now, when it comes to the FJ40, I am trying to keep some originality in here though. And if we jump across to my laptop screen, we can see, while it's going to be a little bit cleaner than what we've got here, we can see the switch gear that is on the dash. And these are sort of pull switches. And I want to retain these, although, as I've said, they'll be a little bit sharper than that when we're finished, I hope. But basically we will be wiring these as wired digital inputs to the PDM in order to control those. Now, I know that a lot of people getting involved in their project cars are maybe put off the idea of running a power distribution module, and yes, they will cost you a little bit more money, but some of the entry-level PDMs now are incredibly affordable, and all things considered, it's probably only going to cost you maybe a few $100s more to add a PDM to your project when you're considering a complete fresh start wiring harness. So it's definitely worth considering for the potential upsides, the amount of flexibility and advantages they offer. And what's really easy to overlook as well is introducing a PDM into your project can actually end up saving you a bit of money, particularly if you're paying a professional to wire up your car, because you'll save on all of the time required to wire up fuses, relays and switches, which is incredibly time consuming. Now, if you are interested in learning a little bit more about power distribution modules, how they work, how you should configure them, how you should install them and wire them, then we do have our power distribution module PDM module course available. It teach you everything you need to know along with worked examples. You can find that at hpacademy.com/courses. Now, I do also want to mention, I should have covered this already, but we are running another one of our giveaways, and this is in conjunction with MoTeC. I'll just jump across to my laptop screen here, right, and we are giving away a MoTeC C1212 dash logger. So that's their big behemoth 12-inch dash. It is absolutely massive. Lots of flexibility in what you can do there. If you want to use display creator, you can incorporate a rear view camera as well. A lot of race cars are doing that, so they've got a rear view display there for the driver. As well as that, we are including VIP membership to HPA. So absolutely epic prize package if you are interested in adding one of the coolest dashes out there into your project car. So you can follow the link that Scott will drop into the comments in order to get your name into the draw. There are 27 days left for this giveaway to run. We have only just recently launched it, so plenty of time left. There is zero cost getting involved. We will ship that prize package, that C1212, to your door irrespective of whereabouts you are in the world, so do not think that you are going to miss out. So again, head across to the link that Scott has dropped into the comments in order to get yourself into the draw. All right, so I've mentioned already the fuel tank that we are building up for the FJ40, which segues quite nicely into our most recent course release, which, if we can just jump across to here, our motorsport fabrication fundamentals course. We released this last week. So I know that a lot of enthusiasts working on their projects, the fabrication side is something that a lot of enthusiasts are put off getting involved with. The reality is it's just like any other aspect of your project, and if you understand the principles, the tools, the techniques involved in fabrication, there's absolutely no reason why you can't jump into these projects yourself. This gives you a lot more control over your project and the sort of results you are able to achieve. So our motorsport fabrication fundamentals course is a perfect jumping off place for those who want to get involved in fabrication for themselves. This course is $99 US. You will see that at the moment we are running a Valentine's Day special, bring it down to $49 US. So it is a perfect time to get this. If you are watching this at a later point in time, I'm sorry that special may have finished. This is only running for the next 2 days, so good point to make. If you are on the fence, please jump in and take advantage of that. We'll scroll down and just quickly go across and view our curriculum. So we cover some of the fabrication tools that you will need in detail here. And when it comes to fabrication tools, you don't need to start by breaking the bank and buying every single potential tool that you may need. A lot of these also are quite cheap and relatively easy to source. And what you'll find is that as you start building on your projects and making them more complex, you can start adding tools to your workshop. Also cover the sort of materials that you're going to come across when it comes to fabrication, and this allows you to understand the pros and cons of the different materials and why you would choose a particular material. We cover personal protective equipment, and I know it's not the most exciting topic, but it is something we do need to understand, and failing to equip yourself with the correct PPE, particularly when fabricating, can be dangerous. I can assure you that the age-old safety squint method is not one that we can stand behind. Design fundamentals, this is a really important aspect of the course in my opinion. When we are designing parts for our cars or whatever our project may be, it's valuable to have some insight into the forces involved and what those actually mean. We don't need to be a mechanical engineer, but just understanding some of these aspects, particularly when it comes to how to use rod ends correctly, and also the aspects of single and double shear, and this is something we see even professional race car manufacturers get wrong. We also cover a lot of the practical skills involved in motorsport fabrication, including design and planning, measuring and marking, drilling, using dimple dies, notching, tapping holes, and a bunch more in there. We also cover welding techniques, obviously critical to motorsport fabrication, and then as an added bonus, in a worked example here, we also will show you in 4 easy steps how to build your very own TIG welding table. Now, why I mention this as well is that we will be adding to our worked examples in this course. The design and construction of the FJ40 fuel tank will be our very next project, but that's also going to segue nicely into the next course we are just putting the finishing touches on, which is our practical motorsport TIG welding course, and that kind of is a nice addition to the motorsport fabrication fundamentals course. Hopefully have that out in the next few weeks, and we know that people are going to absolutely love that. So if you are interested, check that course out at hpacademy.com/courses. $99 US. You can also use our payment plan for that. At the moment with our discount, you're looking at about $6 a week. Normally, of course, at a full price, that'll be a little bit over double that, or around about double that. But either way, very, very cheap. 60-day, no questions asked, money back guarantee, as with all of our courses. So zero risk getting involved with that particular course. Check it out, please. We'd love to know what you think. All right, also if we just jump across to my laptop screen to our Instagram here, this is an Instagram covering our most recent podcast release on the HPA Tuned In podcast. I got the opportunity to speak with Carol from Carol S Motorsport, all the way from Sweden, who is building this insane fully tube framed 1100 horsepower BMW M4, essentially a DTM car on acid. It is absolutely incredible. So we get to talk to Carol about the design and development of this car, in particular the aero development, how he went through designing and building the full carbon fiber body for this particular car. And an interesting an anecdote here, the whole car, the body was actually designed from or constructed based on a 1/16th scale model that was 3D scanned and then scaled up in a 3D modeling software. So a unique option that I wouldn't have probably considered. So if you want to find out a little bit more about what makes this car tick, hopefully it's not too far away from actually hitting the track, check out the HPA Tuned In podcast. You can do that by going to hpa-tunedin.com or search for Tuned In on anywhere you currently listen to podcasts. There are some great episodes. I've really enjoyed producing these. We've had some exceptional guests on the podcast, and it is an absolute goldmine of information. So for anyone who's interested in expanding your knowledge when it comes to the automotive industry, the HPA Tuned In podcast is the perfect place to do so. If you do like what you hear, we'd love it if you could leave us a rating and a review as well. It really helps us grow the podcast, and that also helps us bring in more high quality guests that everyone else is going to learn from. All right, we'll just finish up here, and just a reminder again about that MoTeC C1212 giveaway along with our VIP package, which is, if you're unaware of what VIP is, that's every course we currently offer, as well as free access to every course that we ever produce in the future, lifetime gold membership giving you access to our webinars and our forums as well. Excellent value for money and a huge amount of content in there on a huge range of tuning, engine building, wiring, fabrication, and race driving, as well as race car setup topics. So head along to the link that is in the comments and get your name into the draw. Okay, thanks for watching. Give me a moment here and we will get started with our lesson today.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.